Let's carry on with the file from our previous example. In the last lesson, we took a look at creating a back plot so we could see the Mastercam user interface. We want to expand on that a little bit by learning how we can verify our operations while simulating material removal. The first thing that I'd like to do is expand Setup 1, select Operation 4, and then move my insertion point after that. I'm then going to make sure that I'm on my Toolpath tab and select Stock Model. The stock model is going to allow us to create a version of the part after it's been machined by the previous operations. So to get started, I'm going to name this Setup-1 Stock Model. I'm going to use the stock setup, which takes the original stock size we created inside of our machine group. From the source operations, we're going to select Setup 1 and then say OK. A stock model has similar properties to a toolpath. It allows us to take a look at the operations before it and create a solid model of the version of that part after it's been machined. This has a couple different benefits for us. If we take a look at using these stock models, we can put them throughout. That way we don't have to regenerate these toolpaths to get an idea of what the stock is going to look like. I'm going to move the insertion point after Operation 12. And then I want to take a look at my Verify Simulator options. Inside of the options, note that we can use a stock model, and in this case we're going to use Setup 1 Stock Model. We can also turn on fixtures. So in our case we want to make sure that we turn on Level 201 Fixture Setup 2. Let's go ahead and say OK, select all of Setup 2, and select the Verify operations. The first thing that I want to do inside of the Mastercam simulator is make sure I turn on stop conditions for collision. It's very easy to miss a collision, either going through geometry that should not be removed or hitting a portion of the tool that doesn't have any cutting geometry. So once we have stop on collisions turned on, we're simply going to hit the play button. Now as this goes through our toolpaths, it starts to remove material. And notice that it's paused because we have a collision. If we rotate this around, you can see that it's colored in red, and what we've done is we've actually collided with geometry that's not supposed to be removed. If I simply hit the playhead again, it'll continue through those operations until there's another collision or until we get to the end of the part. We have other options for stopping, such as tool changes or various operations that'll allow us to see what the tool is doing in different areas. Also note down here that we have a differentiation between different operations. We can even go so far as to change the color of the operation and what it's removing from the stock. See here again we have a second collision. If we look at the information on the right hand side in the move list, you can see that this is operation number 1 of 7. Because I know I already have collisions to deal with, I'm going to close the Mastercam simulator and take a look at those back in the Mastercam user interface. To get started, I want to select Operation 6. This is where our first couple collisions were. As we rotate this around, you'll notice that these yellow lines are rapid movements. This is where the tool is moving fast, going from one area to another. To take care of this, what we're going to do is go back into the parameters of our operation. We're going to go into the cut parameters and make sure that we have all of the applicable parameters that we want. We're leaving a small amount of stock on walls and leaving no stock on floors. And everything else here looks good. Under depth cuts, because we are using a dynamic motion, I'm actually going to turn depth cuts off so we only cut full depth in this part. The next thing that I want to do under linking parameters is change my retract to absolute. When retract is set to incremental, it'll move up, in this case, 0.1 inches above its current cutting level. Because we initially had depth cuts turned on, it would go down 1/4 inch or 1/2 inch, cut at that level, and then come back up 0.1 to move over to the next area. Because we have geometry at various levels inside this part, that could potentially present some problems. There are other ways that we can deal with this in terms of avoiding geometry, but in our case we're simply going to change the retract level back to absolute, and we're going to turn off depth cuts and say OK. Notice that operation 7 is also affected because this is a rest machining operation. Let's go ahead and regenerate all dirty operations and let's take a look. So now you can see that we're going down to full depth and all my rapid motions come back up to 0.1 above the part before they move over. Let's take a look at the Toolpath operation 7. Now in this case, we still have some incremental rapid movements, and you'll notice it's going right through this boss. So that's obviously going to present some problems. So let's go into the parameters. Again, we're going to turn off depth cuts, and under linking parameters, we're going to change our retract value to 0.1 absolute and say OK, and regenerate this operation. The next thing that I want to do while the multi-threading manager is calculating that toolpath is move my insertion point after operation 7. Once that's been generated, I'm going to create another stock model. We're going to call this one setup-2 start rough. And in this case, instead of using the stock setup, we're going to be using a stock model from the previous operation. This will take into account all the operations and material that's been removed in setup 1. Our source operations are going to be from setup 2, and we're going to hold down the control key and select operations 6 and 7 and say OK. Once the stock model has been generated, we'll be able to see what the material removal looks like and get a good idea if we accidentally cut through geometry that should still be there. You'll notice in this case we have a problem with the stock model because it's placing it in an incorrect plane. In order to deal with that, we have to go back into the stock model parameters. We need to make sure that the source definition uses the correct plane. Now in this case it's using stock plane setup 2, but if we turn that off and use the top plane and say OK, let's regenerate this and take a look at the results. So you can see because our initial stock was based off of the top plane, we had to change the way our stock model was defined. But if we take a look, note that we have not cut through this boss like we did originally when we were verifying it, and the second operation is not running directly through this boss either. We can also get a good idea of the stock that's left on the walls and maybe areas that we still need to go through. Let's take a look at some other operations. Now if we take a look at this operation, there's a rapid movement that's going through the side here that could potentially cause a collision. So I'm going to go into the parameters. I'm going to go into my cut parameters, make sure that all my settings are okay, go into my contour wall, make sure that all my settings are okay here as well, and go into depth cuts. In this case, I'm going to leave depth cuts on, but I'm going to change machine finish pass only at final depth and say OK and regenerate this operation. Once it's been regenerated, note that our rapid movements are now on the outside of this rather than directly going through this corner. As I mentioned, there are other ways that we can handle this by doing things such as dictating where we want the operation to stop and start, or adding some avoidance geometry. In our case, let's go ahead and simulate all of these. To make sure that we understand that stock models can be based off of previous operations, I'm going to go back into my simulator options. I'm going to change and use stock model setup 2. And in this case, I'm going to select operation 9 through 13, and I'm going to verify those. Now when the simulator starts, you can see that we're using the stock model from our setup 2 that took into account the first 2 operations. This helps because now we can simulate material removal without having to go through the process of playing through those operations again. So this time it's telling us it's been paused due to a stop condition. So it's telling us that it's having an issue hitting something in the corner. We're going to play through. It stops again. And what's happening if we zoom in and rotate this around, the small amount of material that's left on the corner here, when the tool does its lead in, lead out motion, it's contacting that small amount. Now in our case, we're doing this at a feed motion, so it's going to be okay, but we can also take care of it by doing some initial tool pass to get rid of that extra material. So as we play through this, we're going to change the stop on collision option and let it play all the way through the end, and make sure that we don't have any additional issues. I also want to note on the right hand side we have a collision report section, and it'll tell us exactly the areas where it's collided, the move that it was doing, as well as what was in the collision. In this case, the flute length was colliding with the geometry on the outside of this corner. And again, these are things that we can take care of in the operations by dictating start and stop points. If we simply put a start and stop point on the middle of this edge rather than on the corner, we wouldn't be contacting that with our lead in, lead out motions. Since every part and every geometry is different, these are things that you have to come across as you're programming your own part. One last note about stock models as well as the simulator when we're verifying our operations. The version of our stock that's created after a stock model or after verify has been run can be saved out as an STL and used again as stock in another operation. This can be very handy when you're doing multi-flip or multi-machine operations where you want to carry a part that's partially machined and bring it into another operation. It can also help if you're importing cast geometry. So if you have an as cast part and you want to machine certain regions, you can bring that geometry in as your stock or as a stock model and use it in various operations as well as verifying. At this point, make sure that you save your file and that you play around with creating these stock models and verifying your operations. So this way we can move on to the next lesson.